Welcome to Across the Globe. Today we will learn about dictionaries. Dictionaries in Python are collections that hold key-value pairs. Each key within a dictionary must be unique to avoid ambiguity in accessing values. Dictionaries are mutable, allowing for the modification of values associated with existing keys. For instance, a dictionary could be used to store student names as keys and their corresponding grades as values, enabling efficient retrieval and updating of student performance data. Dictionaries in Python are structured using curly braces and consist of key-value pairs separated by colons. For instance, a dictionary named myDict with keys name, age, and city could be created as follows. myDictee name John, age 30, city New York. Printing this dictionary would yield the output name John, age 30, city New York. This demonstrates the key-value mapping, where each key is associated with its respective value within the dictionary. To access values in a dictionary, use the key enclosed in square brackets. For instance, given a dictionary myDict equals name John, age 30, city New York, accessing the value associated with the key name would yield John with the syntax myDict name. Therefore, to modify the value associated with the key, simply reference the key within square brackets and assign a new value. For example, if you want to update the age in the dictionary myDict to 35, you can do so by assigning the new value to the respective key. myDict age equals 35. This operation will alter the value of the key age in the dictionary from 30 to 35. Dictionaries in Python offer built-in methods for various operations. The keys method retrieves all keys in the dictionary, values fetches all values, while items returns key-value pairs as tuples. Additionally, the get method obtains the value corresponding to a particular key. For instance, in a workplace scenario, a dictionary could be utilized to store employee information with keys like name, department, and salary. Accessing specific details, such as an employee's salary using the get method, encapsulates the practical use of these dictionary methods within a professional setting. When creating a student database, each student is assigned a unique student ID. This ID serves as a key to access the student's information in the database. In the given example, a student database dictionary stores student details using their unique IDs as keys, with each student represented as a nested dictionary containing attributes like name, age, and grade. By accessing the database with a specific student ID followed by the attribute key, e.g., name, you can retrieve and display the corresponding student's information. In the provided scenario, calling print student database 101 name will output Alice since the student with ID 101 has the name Alice in the database. A dictionary is like a physical book where words are defined with their meanings and usages. In a program, a dictionary is like a collection of key-value pairs, where each key represents a word and each value represents its definition or information. Just like how you can quickly look up a word in a dictionary to get its meaning, in a program you can quickly access the value associated with a key in a dictionary. Updating a dictionary is similar to adding or removing entries in a physical dictionary book to keep it up to date and relevant. Hey, Code Conquerors! Ready to level up? With TechLearn ATG, showcase your skills with official course certificates. Just visit our site and start. Need that extra boost? Get tailored learning, 24/7 support, and expert guidance. Coding smarter, growing faster, and making learning fun. Go to our website across the globe, www.atg.world. In the provided Python code snippet, a dictionary named AnalogyDict is created to store analogies where each key represents a word and each value represents its definition. Dictionaries in Python are structured data types that allow storing key-value pairs. The AnalogyDict dictionary is initialized with entries for dictionary, program, and update, each with a corresponding definition. This type of dictionary is commonly used to create a mapping between words and their meanings or any other relevant information. To access a specific value in the dictionary, the code uses the key program and prints out the corresponding definition using print AnalogyDict program. A new entry is added to the dictionary by assigning the key with its definition to expand the dictionary's information representation. Furthermore, an entry is removed from the dictionary using the del statement to eliminate the key value pair associated with the word update. Finally, the updated version of the analogy dictionary is printed by iterating over its items. This loop structure aids in displaying each key value pair in a formatted manner. Output. The output showcases accessing a value from the dictionary and displaying the updated version of the analogy dictionary after adding a new entry and removing one. Real-world application. Dictionaries are extensively used in various scenarios, such as storing user information, creating language translators, managing configurations in applications, and handling data mappings in web development like REST APIs, where dictionary data can represent JSON responses. One industrial application of dictionaries is in data processing systems, where dictionaries are used to store and retrieve large volumes of data efficiently. For instance, in a customer relationship management (CRM) system, a dictionary can be utilized to store customer information, with each key representing a unique customer identifier and the corresponding value containing detailed customer data such as contact information, purchase history, and preferences. This allows for quick and organized access to customer data, enhancing the system's performance and user experience. Another real-world example of dictionary usage is in natural language processing (NLP) applications, where dictionaries play a crucial role in language modeling and text analysis. In sentiment analysis, for instance, a sentiment dictionary can be used to associate words with sentiment scores, e.g., positive, negative, neutral. By referencing this dictionary, NLP algorithms can classify and analyze the sentiment of text data, enabling businesses to gauge public opinion, track brand reputation, and make informed decisions based on consumer sentiment. In both cases, dictionaries offer a structured and efficient way to manage and manipulate data, showcasing their versatility and significance across various industries. Across the globe, dictionaries are leveraged in diverse sectors, ranging from finance to healthcare, serving as fundamental data structures that power critical systems and applications, ultimately contributing to the advancement and innovation of technology worldwide. Keep learning, stay curious, and I'll catch you in the next video.